into a few more things. First thing, we are going to talk about continuity, or where graphs are continuous. And continuous just basically means you can graph it without picking up your pencil. Okay, so if I can draw the whole thing without picking up my pencil, this is a continuous function. Okay, that's continuous. But if I have something like this, it is not continuous because I have to pick up my pencil to jump from that section to the next. So it's all something you can trace without stopping. That's continuous. If you have to pick up your pencil, it is not continuous there. We will use intervals to name where something is continuous. And when writing intervals for continuity, use the x values. Okay, just like when we talked about increasing, decreasing, constant. We would give an interval where a graph was doing those things, and we always had to list the x values where the graph was increasing, decreasing, constant. So same idea, x only. When is the only time we use the y values in an interval? If I'm asking you to list range, that would be the only time you would use a y. Everything else is x only. And the reason, because on the function, if I say 3, if I'm talking about x, there is only one place where the x is 3. But if I'm talking about the y, could there be multiple places where the y was 3? Mm-hmm. Yes. So it's because the x doesn't get repeated that we always use that interval. So let's look at a graph, and we are just going to write the interval where it's continuous. On this first one, I apologize. That is an open circle right there on the 2. The tick mark of the 2 really made it look close. So that's supposed to be an open circle. So if I am graphing this, I can do this whole section without picking up my pencil. Then I have to pick up and jump over and draw the racks. So if I'm giving my interval, it's coming from negative infinity. It's continuous until I get to what x value? 0. I have to use a parenthesis there. It's an open circle. We're not equal at 0. That's where it stops being continuous. And then it's continuous again from 0 to infinity. So everywhere except that point when x is 0, our graph was continuous. What about b? You're tracing that. How many times do you have to pick up your pencil? Never. So where is it continuous? Infinity, positive infinity. Continuous the entire time. Okay, try C and D. Where is C continuous? All right, and what about D? All right, can we identify where things are continuous then? Okay. So, the next we are going to get into all of our common functions. And the identity function, this is the most basic of functions. F of x equals x. That's like y equals x. What is that? Straight line. What's your y-intercept? 0. Slope? 1. Up 1 over 1. So it's like your points 0, 0, 1, 1, 2, 2, 3, 3, or you could go negatives. I want to answer some questions about that. Can you tell me the domain? What is the range? Okay. Is this function increasing, decreasing, or constant? Increasing, because it's rising from left to right. So it's increasing the entire time. Is it continuous? Yeah, from negative infinity to positive infinity. No breaks in that graph. All right. Identity function okay with everybody? All right, our square function, f of x equals x squared, or y equals x squared. We haven't talked about this year, but you have previously. What is that? Parabola. So, if you don't remember, and we're trying to avoid just using a graphing calculator, how do you get points on a graph? Yeah, make a table, XYT chart. And so you can certainly do that at any point. Make sure you put in positives, negatives, and 0. 0 squared is 0. 1 squared is 1. 2 squared is 4. Negative 1 squared, negative 2 squared. Plot those. And you could certainly do more points if you wanted. 3 squared is 9. Negative 3 squared is 9. As a general rule, I usually tell everyone a minimum of 3 exact points. And then from there, if you know what your graph looks like, you can finish it off. But if you're not sure, always just put in more points until you get it. What's the domain of that? Because it keeps extending left and right. What would be the range? And the 0 will get a bracket because it does hit 0. Increasing, decreasing constant. What does this graph do? Starts off decreasing from where to where? And then what does it do after 0? Increasing from 0 to infinity. Increasing, decreasing, it doesn't matter if you do a parenthesis or a bracket there. This one is never constant. Is it continuous? Yes, the whole thing is continuous. We drew the whole parabola without picking up our pencil. All right. What about the cube function? So, you guys remember what that looks like? Close, yeah. So, we kind of have an idea. Let's get some points. If I put in 0, 0 to the third, okay. If I put in 1, 1 to the third. If we put in 2, 2 to the third. Oh, what would happen if I put in 3? 27, so that's huge. Let's try some negatives. Negative 1 to the third. Negative 2 to the third. So this is like our chair function. What is the domain? What is the range? Is this increasing, decreasing, or constant? Increasing the entire time as you go from left to right. It's always rising. So negative infinity to infinity. Is this one continuous? Any questions so far? If you had to, could you make a table of values and draw these graphs on your own? If you needed a rest day. Okay. Let's talk about the square root. Anybody remember what that looks like? Have you seen that one before? I don't know if you really know. That's a 1 over x. Is what you're... Okay, let's figure it out. If I put in 0, what's the square root of 0? 0. If I put in 1, what's the square root of 1? 1. Is 2 going to be a nice number to put in? No. What would be a nice number?
4.
What's the square root of 4? Right? What's another nice number? 9. Square root of 9? Okay. We didn't do any negatives. What happens if I put in a negative? Imaginary number. Can we graph the imaginary numbers? Nope, so I can't put in any negatives. Make sure then you realize when you draw this graph, it's only extending in the positive direction. It doesn't go in the negative direction. You flip your ass. What's the domain? And it would get a bracket on the 0 because it starts with a closed circle. What's our range? Increasing, decreasing, or constant? Increasing the whole time, 0 to infinity. Where is this continuous? 0 to infinity, same thing for all of them. Cube root. If I put in 0, what is the cube root of 0? I put in 1. What is the cube root of 1? Can I do the cube root of 2? What's a nice number? And the cube root of 8 would be 2. Can I do negatives? The cube root, if you multiply 3 negatives, you still get a negative. So you can do the cube root of negative numbers. Odd roots of negatives exist. What is the cube root of negative 1? What's the cube root of negative 8? So this is kind of like a chair flipped on its side. The cube function flipped on its side. What's the domain of that? What would be the range? Is this thing increasing, decreasing, or constant? Increasing the whole time. Yeah, is this one continuous? Can I draw the whole thing without picking up my pencil? Yeah, so if I asked you where, you would just say name thing to the whole thing's continuous. Okay, I want you guys to graph this one. So get some exact points, make your table of values. Table of values, absolute value 0 is 0, absolute value just makes things positive, so 1, 1, 2, 2, negative 1, 1, negative 2, 2. So it looks like that. What's my domain? What is the range? Right, 0 gets a bracket, we do hit that. Increasing, decreasing, or constant, what does it do? Starts off decreasing from negative infinity to 0, and then it increases from 0 to infinity. Is this one continuous? Yes, all the ones we've graphed so far are continuous from negative infinity to positive infinity. None of those have any breaks in their graph. Increasing, decreasing, remember, if you put a bracket, that is the same on those. The way it's defined, you can't be going up or down at this particular point. So it doesn't matter if you do parentheses or brackets. Alright, so those are the common functions. When we start doing transformations in our next section, we'll do transformations on all of those functions. We also need to talk about graphing piecewise functions in here. So every piecewise function is different. Piecewise just means you have multiple rules. You have different things you do on different parts of the domain. Do you guys remember how you graphed these in the past? What do we do in general if we don't know how to graph something? No. Make a table. Okay, so we're going to make a table for you. Okay, here's where people make a mistake though. They see, we use this first piece when x is greater, or when x is less than 1. Can you give me the first number smaller than 1? 0. What about 0.9? Is that smaller than 1? What about 0.999? Is that smaller than 1? Can you give me the absolute closest we can get to 1? No, because I could just always add another 9 on it, right? So we still have to plug in 1. Even though it doesn't say equal to, we have to plug it in because that is our starting point. But how do I show on the graph that it wasn't equal to there? Open circle. Yeah. So since that one didn't have an equal to, I'm going to make myself a note it's an open circle. But then the other x's I put in are anything less than 1. So I could do 0, I could do -1. More points if needed, but at least 3. And I'm plugging them into my rule. 2x plus 4. So 2 times 1 plus 4 is 6. So 1, 6 is an open circle. Now that is the only open circle. Everything else is closed. It's just that starting point that was open. So then if I put in 0, we get out 4. So 0, 4. If I put in -1, I get -2 plus 4, which is 2. Okay, and we could certainly keep going, but when I go to graph this, I started here at my open circle, and I was only putting in x's smaller. So when I draw this line, it is only extending to the left. It was only for the smaller x's. It had a open circle to start with, because it was only true for the x's less than 1, not equal to. And then it extends to the left. I look at the other one. We need a separate t-chart for this piece. What is the first x value we have to put in? 1 again, but this time it will be right, greater than or equal to. So because it's an equal to, it's a closed circle, I don't have to worry about that, and then I put in things larger. Maybe a 2 and a 3. So if I put in 1, 4 minus 1 gives me 3. 4 minus 2 is 2. 4 minus 3 is 1. So we started here, it was only for the x's greater, so this extends to the right. Quick check at the end. This should be a function, so it has to pass the vertical line test. So if you messed up and extended one of your lines the wrong direction, you should catch it then. That's also a good place to check and make sure I don't have 2 closed circles on top of each other. Okay, so you can find your errors there. Let's answer some questions. What would be the domain of this? The blue piece came from -infinity. It stopped at 1, but the green picked up at 1 and kept going forever. So my domain is -infinity to infinity. My range, both of them are going down forever, so it's coming from -infinity. The green one stops at 3, but the blue's still hitting things. It doesn't stop until I get to 6, but I have an open circle there, so 6 would get a parentheses. It's not equal to the 6 because of the open circle. Can you tell me, where is this graph continuous? to 1. That was an open circle, so it gets parentheses. Union, the green one started at 1 with a closed circle, so that would be a bracket 1, 2. So it has 2 separate pieces that are each continuous. The whole graph isn't, but each piece is. Any questions on that one? Mm-hmm.
How is that considered continuous?
You're telling me where on the graph it's continuous, the intervals that are continuous. So I can go from -infinity to 1 without picking up my pencil.
Okay.
And then I can go from 1. No, it's okay. Any other questions? Let's do one more of those. Right. So if I make my t-chart, for the first piece, what would I need to plug in? 0. Is it going to be open or closed? Closed. I don't have to worry about that. And then what kind of x's do we need to put in? Has to be less than 0. So maybe -1 and -2. Okay, so the opposite of 0 is 0. -2 is -2. The opposite of -1 would be 1 minus 2 is -1. The opposite of -2 is 2 minus 2 is 0. 0, -2 is closed. 1, -1, -2, 0. So I'm starting here. Only for x is less than, so it's only extending to the left. The second one. What would be the first x we put in? 0, but it doesn't have an equal to, so it will be an open circle. And then we need things bigger than 0. So I put in 0, 1/2 times 0 is 0, minus 2 is -2. If I put in a 1, I get 1/2 or 0.5 minus 2, so -1.5. If I put in 2, I get 1 minus 2, so -1. So 0 and -2, I said open, but I already have a closed circle there. What does that mean? It just stays closed. Okay, I don't want you to draw an open circle around it. If there's an open and a closed, same spot, it's just closed. So then 1, -1.5, 2, -1. What would be the domain? What is my range? Where is this graph continuous? Because my open and closed circle joined, it made the whole thing continuous. Negative, negative, positive. Any questions there? Okay. So I think I'm going to stop because I want to hand back the